Hey there, my name is Alex Hodgson. I'm an applications chemist here at VUV Analytics. In this episode of Applications Briefs, we're talking terpenes and how we can use the VGA-100 here to overcome some of the obstacles that traditional detectors like mass spec can encounter. Terpenes are a class of organic compounds that are mostly produced by plants and contribute heavily to their odor and flavor profiles. So any industry that produces something that you smell or taste, essential oils, flavors and fragrances, pharmaceuticals, cosmetics, they're all going to be interested in these terpenes, whether they're synthesized or naturally extracted. Terpenes are built from units of isoprene, which is a C5-diene. Because they're all built from these same building blocks, we get this large array of isomeric configurations that contribute to these flavors and fragrances. And traditional detectors like mass spec are going to struggle with isomers because they have identical mass spectra. So you need baseline separation, which leads to longer run times. And FID in general struggles with co-eluting peaks. But that's where our VGA-100 comes into play. As I mentioned before, traditional detectors like mass spectrometers are going to struggle with isomers because of their identical mass spectra. But because these isomers have unique three-dimensional electronic configurations, when they are hit with VUV light, they produce unique absorbance spectra. So when we go and deliberately compress the chromatography, we can use these unique absorbance spectra to go back in the software and deconvolve these co-eluting isomers. And in this next figure, we will look at some of these absorbance spectra and what makes them unique. In this first figure, we see the absorbance spectra of 6 monoterpene isomers. In mass spectrometry, they will have similar, if not identical, mass spectra, which makes identification and quantification difficult. And even though we see compound class similarities in the absorbance spectra, such as with cis and transosamine, they still produce distinct absorbance spectra that will allow us to do a deconvolution once we've compressed the chromatography. This next figure shows a chromatogram of our terpene standard mix. Traditional runtimes can be upward of 30 minutes, but with an increased flow rate and oven ramp, we are able to compress the chromatography to a sub-9 minute runtime. Compressing the chromatography to this degree causes multiple co-elutions, but with our software, we can deconvolve these co-eluting peaks, and we'll take a closer look in the next figure. In this final figure, we look at some of the co-elutions that are occurring in the early part of the chromatogram. Using traditional chromatography, we would have to drop vertical lines between these co-eluting peaks, leading to ambiguity in our quantitation. However, we can use the spectral data and unique absorbance spectra of these analytes to deconvolve these co-elutions, leading to more accurate quantitation. You can see on the right side of the chromatogram that we have multiple co-eluting peaks, but our software can easily handle this. I go into a full breakdown of these co-elutions in my blog. Using this method, we analyze terpenes from 6 essential oils using headspace GC-VUV. In the simpler odor profiles, such as sweet orange, we only see one peak of interest, that being limonene. In the more complex odor profiles, such as tea tree or lavender, we see multiple peaks of interest. One interesting aside is that the neroli oil did not actually contain any nerolidol, which would make this method good for authenticity screening. We also analyzed terpenes from 3 different gin samples using SPME GC-VUV. As expected, the higher quality gins use a wider array of ingredients, which led to a larger and more diverse flavor profile. And these flavor profiles were down on the picogram level, which highlights the sensitivity of the VGA-100. Thanks for tuning into this episode of Applications Briefs. For a full write-up of this terpenes application, follow my blog, Better Living Through Flavor Chemistry, at vuvanalytics.com. I will also be presenting this information at HTC in Cardiff next January.